time for us to move to the panel discussions. If you need any more information about software, you can get my name card at the end of the session, or you can just drop me an emails. All right? So while I'm introducing the panel, can I ask the panel to bring the chair to the front? So now to broaden the conversation today, we'll bring in perspective beyond technologies, Dr. Stu. And joining us today are Tina Koppejan in green. Tina has 2 decades of experience of shaping energy transition policy across Asia Pacific and Europe for Shell. She now leads White Leaf Climate, a strategic policy advisory focused on scaling climate tech and accelerate industrial decarbonization. And the third panel today is Sharon Goh in blue. She is a senior lecturer at National University of Singapore for Engineering Design and Innovation Center. Previously, Sharon held senior regional roles at Total Energies and Shell. She was recognized as Sustainable Energy Outstanding Achiever by Global Green Economic Foundation. Together with Dr. Stu, they will help us explore how data center can balance innovation, compliance, and environmental sustainability. So let me put up the panel screen. All right. So the first questions for everyone, maybe for Dr. Stu and Tina. What do you think is the biggest challenge in data center today? Tina, do you want to take the question first?
Yeah, sure. No, it's fine. I cannot put it on the slide because I find typically with panel sessions like this, it's kind of easier to visual aid. If you can literally see the words behind me while I'm addressing them. This is also a way to remind myself what I'm going to say. So my background is in policy making within an energy major. What that means is, what I've done is I was helping to drive Shell's business growth by developing enabling policies that would help the business to grow and make money. So my perspective is very much that from a policymaker, even though I didn't work in government, but from an industrial side. So when we were preparing for this panel session, and Patricia said, okay, so from your specific perspective, like semi-government policy expertise, what are the biggest challenges? I immediately thought of these 3 things. One, and I think that's already discussed a lot, so that's not new to you, land use and social license to operate. So if you're coming from the oil and gas industry, license to operate is a very common term, but actually literally means what it says, license to operate. A societal license to operate means that people don't fight you with tooth and nail, they actually welcome you, they see what you can do for the community, and you're kind of allowed to be there without the government mandating the community to accept you. Land use, and I think Stu kind of made a point around that, or maybe that was when we were having food at the front. Data centers, any kind of industrial hub, they are never built in the middle of nowhere, right? Because any kind of industrial hub, what they need is good quality land, basically, because they need access to energy, whether it's on-site or off-site. They need water, they need access roads. So there's a reason why industrial hubs everywhere in the world, whether it's a refining site or whatever, they are like next to a harbor, next to where the roads are, next to a power station, etc. So data centers are competing with other industrial developments for good quality land. So I think that's one tension that we already see arising, and because of that competition, there's absolutely a lot of discussion around what is the data center's societal license to operate. Because you guys come here, you build a gigantic industrial facility. What does that bring me? What does that give me? I can see maybe what it does at a national scale, like maybe it adds to digital resilience and economic competitiveness, but what does it actually give me? Because I don't actually know. So I think that's one tension that data centers are currently struggling with, one challenge that data centers experience. The second one, again, this is not new, because that has been a point of contention all over the world. The way that data centers impact the load of the power grid vastly outpaces how power grids are being managed and growing at this moment. It takes about a good decade for any government, national as well as regional and local, to plan any kind of power grid extension. Data centers, first of all, data development, they grow much faster than a decade. Second of all, if you think it from a planning perspective, governments they know how to plan for essential infrastructure, right? Like power stations, like I said, or even highways, or the next industrial hub, or extensions to harbors. They know how to do that. Data centers, they have no idea. It's basically a wild, wild west out there, which impacts the data center's societal license to operate. The third one is, and I think all these 3 points kind of build on each other. When I say governance, you need to think about how is the growth of anything governed? Like, what are the rules that apply? What are the boundary conditions? How is community involved? And again, governments know very well how to do this. If you would build an offshore wind park right now, or maybe not in Singapore, let's take as an example, we all know the Singapore government is looking at floating SMR, right? There's a huge process going on behind the scenes. The Singapore government is talking to a wide variety of stakeholders. They're also talking to governments across the border. How are we going to do that, and etc. For very obvious reasons, because we're talking about nuclear energy. When it comes to data centers, basically it's every government for themselves. But that shouldn't really be the case. And even within the domestic borders, there are hardly any rules that currently exist. For instance, if you want to expand a highway, to easily extend that to the growth of data centers. So I hope you can see how all these 3 points kind of build on each other, and it kind of leads to one big question, which is, what is the role of data centers in our society today and tomorrow?
All right. Thank you, Tina, for the comprehensive answers and the high-level perspective on the biggest challenge of data center. So now hear from Stu. What do you think is the biggest challenge of data center today?
Yeah, I think it's an opportunity really. So I think following the liquid cooling transition and the split I was talking about, the hybridization, the split between air and liquid, as that improves and the ratio becomes more and more towards the liquid side, and as the temperature of those liquids increase, I think it's a massive opportunity. I think in our lifetimes we might see the removal of refrigeration out of IT cooling. We're getting to a point now where the refrigeration cycle is becoming optional and could be completely eliminated. And I think as a heat transfer guy, that's just going to be the most amazing time where we can finally get to incredibly low PUEs all around the world, and that will contribute a little bit to helping us keep things more efficient. So that's the one.
All right. So following that questions, how do you think we can resolve these challenges, Dr. Stu?
I think it's going to be a natural consequence of the limited resources we have available. It will become economically viable to push engineering, to push the technology really hard, to solve those problems of squeezing that gap until the window of operation for refrigeration becomes zero, and you can do that reliably, sustainably on every data center around the world. I think that's the economic driver that we're in at the moment.
That sounds very challenging. So, Tina, in your experience of oil and gas industry, the most regulated industry, how could data center address the requirement for carbon reporting better?
Yeah, could you pull up my second slide so I can remind myself?
Sure.
But I will let you share with the audience. I think you already had it.
This one?
Yeah. So in oil and gas, nothing moves before it is defined what is it, what is the scope, what are the boundaries, and who owns it. The oil and gas industry, like I said, is maybe not the most regulated, but definitely like pharma is probably right up there as well. But it's definitely, when it comes to emissions, GHG emissions, it's not just carbon, but when it comes to greenhouse reporting is probably one of the most regulated industries in the world. So having very clear idea, definition of what is it and who owns it and where is it moving, that's kind of the starting point of any kind of robust, I would say, GHG emissions reporting. And I think I had no idea what EkkoSense was actually doing because Patricia only showed kind of a demo for us because I'm not an engineer. My background is in international tax law. I thought it looked really snazzy, but then when I was listening to Stu's presentation, I actually think that the tool, and this is not a sales pitch, I make no money from, I'm not a marketer for that. Because it kind of builds onto my next point, in which I think that EkkoSense does very well, which is integrating carbon GHG reporting. Let me just put this broader, because like I said, there's so much more than just CO2. Integrate carbon reporting into operational governance from the start, not as an afterthought. And I see someone here on the front row nodding, and I think as engineers, and some of you, I saw from the first question, has operational experience or currently work in operations. This completely makes sense, right? Right now, I can tell you GHG reporting very often, yes, but the data comes from your department, but the actual production of the reporting is with a sustainability department, somewhere in headquarters in an office, which is a sustainability team. Any kind of sustainability team, any company right now is staffed with a wild variety of skills. Not all of them will have technical or operational skills. So to incorporate your GHG reporting data into operations, maintenance, procurement, vendor management, right? That's where that kind of integration from the ground up, that's where it starts. And then when the data gets pulled together in a nice package for people that are not technical, and then they can actually submit it to a regulator and then say, this is actually credible data because we stand behind it. So I think that's the second way. And then the third one is kind of just an extension of that, building to your workflow. And I don't want to repeat myself, but I think that kind of intuitively makes sense.
Very interesting, very interesting. Thank you for the highlight on EkkoSense.
Again, I'm not making money off you, but that's because when we were preparing for this session, actually one of the things I said to Patricia is, even though EkkoSense 2 looks really snazzy to me as a non-engineer, I also don't play video games, but it looks really snazzy to me. I can tell you from experience, that's not what regulators care about. Think of it as when you do your annual tax submissions, you can use and buy the most expensive tax, like income management tool of any software supplier on the market, and then they will say, yes, I will produce like the best looking tax report which you can submit to IRS. IRS literally does not give a shit what the tool looks like. What IRS cares about is that every number you submit is accurate, verifiable, and traceable. That's all they need to know. So I think the snazzy looking interface is very useful for the people using on a daily basis, because I do like the level of detail that it's giving, and I absolutely like how small the thing is. I walked around on refineries, on like a lot of industrial sites. None of it has that size, so it looks great. But the outcome that you could probably pull out from EkkoSense 2, that's what regulators care about.
All right, thank you so much. Thank you, Tina, for the answers. So now the next questions for Sharon. In your experience as innovation expert, how would you recommend data center today to innovate and achieve the objective of net zero in 2050?
Okay, thank you for the question. Yeah, you can click to the next slide. Maybe I can also just share a bit about my experience when I was leading the regional innovation for Total Energies for APAC and Middle East. Because what happened is when Total changed to Total Energy, that's where we grew from just oil and gas to also multi-energy. Looking actually into data centers, because I was working on the projects that were dealing with the immersion cooling liquids. So that was when I dealt with data centers that are beyond Singapore to other countries. So before I maybe elaborate further, I'm actually interested to know how many of you are just mainly working on data centers in Singapore? How about data centers in the region, ASEAN, or even globally? You are doing global work also. So do you realize that as you are working with different countries, there are different rules and different policies that we have to take note? and even amidst that, there's also the culture. So what I wanted to highlight here is to innovate. One thing we can look beyond is actually to create some sort of, to think about the idea of an ASEAN data center innovation landscape. For one thing, Singapore is known for its subsea cables. We have the most subsea cables to support our data center infrastructure. That is what makes us different, but we are also expensive. We have land shortage. But if we look across Malaysia, Johor Bahru or Batam, where our data centers also overflow, the land is cheaper, but then there's a need to create more advanced technology. And then if we look at Vietnam is they're trying to build more subsea cables, they're trying to build 10 more. But like you said in your poll, you mentioned about technology integration. So this is where like different countries have different challenges, but what remains the same, is that if we connect our energy infrastructure and policy, then that's where the key innovation areas we can work on is on the energy efficiency, advanced cooling, renewable energy, resource optimization, digital and AI enablement, and resilience and security. And I think that's where EkkoSense AI actually hits all the boxes here in terms of the digital AI enablement and also that security. Also not paid to advertise, but might as well. Yeah. Okay. So this is where I think it's interesting. Then we can take a picture before I talk about the next slide. Yes. Okay. So just strategically, these are just 3 keywords I want to tell you all. So when you design a data center roadmap to 2050, because just now I showed you all the region, but if you were sitting there as an engineer or as a strategist for your company, the roadmap would be to optimize, decarbonize, and transform. Think of it as, lately I just moved house, so this is how you can think of the house. You first have to declutter. So in optimizing, right, you have to really think of all these resources you have. How do you improve that efficiency? How do you make use of the resources you have to already improve that advanced cooling? How do you reduce the emissions with what you have? And then in terms of decarbonization, that's where you think at home, maybe, okay, I have time for me to buy new things to fill the gap. So decarbonizing, that's where you actually get into buying, investing or starting new renewable projects. And then energy integrating new energy, like what we mentioned a lot about water cooling or even EkkoSense AI, to actually score well in your green financing. Because I've read a lot of data center case studies, and that's where me and Stu were just discussing. There's a data center here from Australia that scored very well because with more renewable or with a higher your power, your water, and your carbon usage efficiency. That's where you get a higher sustainable income, which is a big score point in Singapore, which also makes Singapore very, very lucrative because Singapore is such a grant giver. It's a very good place that gives grants to promote the building of data centers, unlike other countries. And lastly, I'll talk about transformation. That's where from 2040 to 2050, like eventually if I build a home, I feel in the gaps, I create new things, I want to start a family, I want to make this a home forever. So the aim that data centers, especially in Singapore and what the government is also favoring is the transformation of 24/7 carbon-free energy and the circular economy and your net zero. So that's where, enabler-wise, I think that's where I shared further through the examples I shared through Singapore government. And if you click one more, the success metrics I would say is to really look at the power usage PUE. 1.2 I would say is a bit more relatable. And then renewable energy, I think by 2050, the government hopes that we will hit 100%. We try our best, we try. And then carbon intensity, scope 1, 2, and 3. And that is why I think when Patricia asked us to do this, I think it's very exciting because I believe in it, but I think it's something that is very interesting and it's a game changer for the data centers. Yeah, so with that, these are things that I feel that we could innovate on. Thinking of how we do our decarbonization projects or innovate, just like thinking how we improve our homes. Yeah, thank you.
All right. Thank you, Dr. Stu, Tina, and Sharon for the interesting insight about data center from oil and gas industry as a technology perspective, as well as the sustainability and innovation side of way of thinking. Yeah, so we like to take questions from the floor. I see there's already a few questions in Mentimeters. First one, I think you have already addressed this somehow in the questions, but why this region is attractive as data center hub? What kind of, okay, maybe that's the first question. Why this region is attractive as data center hub? You want to take the first one, Sharon, or Tina, or Dr. Stu?
Maybe so as I maybe just summarize a bit as mentioned, Singapore is very lucrative because of the subsea cables. I believe that's the number one point. Second point is with the IMDA data center green roadmap. I think they've been very, I think they really give good grants. I think the shortages, as I mentioned, is probably our land shortage. And that's where I think some of you are dealing with data centers across different countries. How can we leverage that? And knowing that now Stu stays in Malaysia, and I think it would be interesting to hear how is Malaysia doing or favoring the data center role. We're actually interested to hear more.
From what I've learned, because it has the space, it has access to a lot more water, but the government's concerned now, so they are definitely starting to throttle back on traditional style of data centers and promoting AI data centers. So they've made a strategic play there to make sure that what is being built going forwards to utilise the capacity they have available is dedicated to the most advanced kind of compute that we have. And I think it's a credit to them that they've made those kinds of decisions to try and be at the forefront of something, rather than the kind of following on where other countries are. But there will be many impacts when they do that. But they currently have a lot of conventional data centers on the build, so it will take a while to fill up and populate what they'll be building. But they have made that strategic decision to just focus on GPU style going forward.
I think if I can add from a macro level, if you think about why does any government attract industrial activity to their own country, right? So Singapore has some very unique features, but then again, so does Malaysia, Philippines, Vietnam. They're also all putting a lot of incentives in place to attract that. A couple of reasons. The ASEAN does have enough land, more than for instance Japan, Korea, Taiwan, to build data centers. And data centers, like I said, does require a lot of land. That's one. So there is a lot of land available in Southeast Asia. It needs to be developed, but that's what the Chinese companies are really good at. So land availability, then availability of renewable energy. Because this is something that's actually quite unique to this region. There is geothermal, hydro, solar, onshore, offshore wind. It's dispersed, and it's not easy to develop, but it is. Thirdly, the global south, in every macroeconomic report, is where the future demand for energy will be. It's already here, so that demand will only grow compared to stagnating regions like North America and Europe. A fourth driver, which has actually nothing to do with any country's natural resources, is also maintain your economic competitiveness and your digital independence. That's regardless of whether you actually have renewable energy. And let's face it, like the subsea cables that Singapore has is kind of a fluke, a legacy from the past that they are leveraging right now. But in this world, if you're not digitally independent, then you are dependent from others. Even in Europe, especially Western Europe, that's actually quite densely populated, and I just had a good discussion with Stu about that. I left Europe a couple of years ago, so I haven't really tracked the discussions there. And I asked, what is the data center growth? And he says, yeah, definitely Ireland, Northern Europe, the Scandinavias. There's also a really intense policy debate going on in Europe about, you know how Europe is really progressive when it comes to green target, net zero targets, and etc. So there's also a very intense policy debate about what is the role that data centers play in our society. Yes, we want to remain independent from the United States or from Asia, but can we even build it here? And if we can build it here, how are we going to do that? And then you get into the land use, water use, energy use discussion. So I think there are kind of macro levels and not exactly micro, but like like regional and national drivers to the question, why are data centers here?
Yeah, that's definitely interesting discussion that has been happening in Singapore, and why this region are interesting for me to be in the data center. There are several of technical questions for, I'm not sure if you want to answer this now, but how wide an area can one sensors cover? I guess they're talking about that. And how easy or how often does the sensors need to be calibrated? And other than sensors and digital twin application data hall, can the application be scaled up to the whole DC campus?
Okay, so I'll do it quickly. So, because we want resilience on the wireless sensors, we tend to put a number of receiving hubs in to be able to pick them up. So we always tend to put more hubs than we need, but each sensor has a transmission range of about 30 meters or so within the hole. So we always make sure that we put far more hubs in receiving stations than we need to take care of that. The calibration thing, because we have such close, we see all the data that's coming out of all the sensors, and we have a lot of machine learning running on it. We constantly track how they're performing over time, and can see if there's any variance on how sensors are performing, how they're doing against their peers, and it's something we monitor really closely. And it's very rare, but if we need to, we can single out individual sensors that have any problems. It's not really a big issue for us. And the last one on the whole campus, we tend to work very closely with BMS systems. So at a certain scale, we obviously really specialise in the white space and supplementary information from grey space on chillers and pumps and other things. But we tend to, there comes a certain point where we tap into BMS data, or BMS systems share our data. So campus-wide or SCADA type applications, there's a crossover where we start sharing each other's data. So we sometimes represent their data, and BMS systems sometimes use our data, so they get a view also. So that would be how we do campus-wide integration.
All right. Okay, so let's take another question about, can you help DC operator to distribute load in an energy efficient manner?
So if by load you take a greenfield site and you want to populate it, where to put the racks down, so if it's absolutely yes, so our zones of influence have a really good innate understanding how much capacity there is for any given square meterage of a data center floor. So that's a fundamental part of what we do. At higher levels, yes, we have a really good understanding of the amount of available cooling in each individual room, the amount of capacity on chillers. So yes, we can help a lot with allocation and benchmarking, room capacity, site capacity.
That is statistic means which you're using for your optimization. My point was the DC operator has a dynamic load, has customer compute need,
Yes.
day times, night times, or on a cloud provider you would have different needs, customer coming in.
How we deal with that, it's in depth, but for each individual rack, you can reserve and allocate power depending on the contract that rack has.
Okay.
So of course, we can see its power fluctuation over time, as you would expect, it goes up and down, but that's not part, it's an interesting part that sometimes we can talk about, but we also know what a rack is allocating and how much power is reserved for it. And that's part of an operational discussion with the site team. So you might, in Colo for example, you might sell a rack out of 10, but it's only ever using 2. There are ways to manage that kind of capacity.
Okay.
So we do have the data, there are ways of displaying it. Sometimes there are opportunities to optimize. I think it's the point you're getting that you just can't touch, because that customer has reserved that capacity and they may use it tomorrow. And we, of course, have visibility of that in our tool set as well. So you can just reserve and allocate additional capacity for a zone, a room, a floor, and that's just part of life, isn't it? So, but our job is just to, where that's not the case, to take advantage of it. Where it is the case, make it very visible. And then it's a negotiation. So then it might be something that a particular customer or end user wants to reduce, or they may not.
I can explain to you a little bit more maybe after the event. Okay, so the next question that we have, how would EkkoSense stand out among the other competitors in operating DC?
So in our world, we tend to see, if it's DCIM, if you like, so BMS at one side, so hardened devices that need to look after security, fire systems. There's always a demand and always a need for that kind of infrastructure. In the DCIM bucket, there are DCIM providers that are very strong on IT systems, so patching, cabling, contents of the rack. We don't do that. So in our ecosystem, when there are opportunities that have a very strong IT angle to it, we tend to stay away from those. That's not our angle. But when we do see applications that are very infrastructure based, they're about cooling, energy, risk, diagnostics, anomaly detection in cooling systems, power systems, EPMS type angles, then that tends to be where we have a particular strength, and we're slightly unusual in that side. Amongst our competitors, most of them are a bit stronger than we are on the IT side of it, and we tend to have an advantage when it comes to cooling and heat transfer for obvious reasons. That's where we've really focused our business.
Maybe I can add to what Dr. Stu states. You can see it in the slide. Sorry, sponsored message. So what differentiates us is, besides we have established 15 years ago, so we have track record, we have been installed in CBRE, Citibank, Telehouse, Visa, a lot of global data center worldwide. We are quick to value because of pricing structure, integrate and ingest because we are very hardware easy, that means very less hardware. Easy to use, we built in the gaming platform, 3D digital twin drag and drop system. Immediate insight where we can get the data immediately after you install the sensors, because once we commission this, which is just a plug and play system with a QR code, you can get the data almost immediately. That means it's already the display connected to the cloud and all preset before we come into your data center. Minimize risk, because with our, on top of the existing VMS and DCIM, what differentiates us is also our machine learning and our machine learning algorithm that can tell you if there is a possible challenges that you could face with your assets in the futures. And stay in the know, because our reporting system is very easy to customize and very easy to access. You don't have to go through 3 different people to get your report, know what's going on last night. You can just go to our platform and check it out in the morning, wherever you are. I'm sorry, even if you're on holiday, you can still access that as well. And know what's going on in your data hall. So if there is any report last night, you can verify the data immediately. If you need any more information, feel free to reach out to me after this event. Then the next question, maybe let's take questions for policy. How can policy keep up with the explosion of compute requirement due to AI? Maybe Tina or Sharon? Tina.
So right now what we just objectively observe is that policy is not keeping up. Because policymakers are really struggling, first of all, to probably understand what even the problem is, then the size of the problem. People very often forget when. So I'm involved in my daily job in mostly like decarbonization questions or energy transition. And I very often say in 2026, it's not difficult to understand what energy transition is, by the way. Everyone anyone, unless you're an energy expert, underestimate the size of the problem. Like how much does a regular household, building on Sharon's example, how much does a regular household use, then at a neighborhood level, then a country level, city, etc., etc. Same with data centers. I think we are barely, as a society, barely grasp what the problem is and the size of the problem, let alone how to deal with it. Coming back to my earlier point about lack of governance, what governments do know is how to include, for instance, let's say there's an extension of the harbor, right? Singapore is one of the busiest harbors in the world, industrial harbors. There's a huge discussion right now ongoing, led by the Maritime and Port Authority, about Singapore Harbor wants to become a multi-fuel supplier for any kind of ships that wants to bunker here. So Singapore in the future wants to offer and biofuels and bio-LNG and hydrogen, but also biokerosene and etc. So Singapore government kicked off an entire process like stakeholder consultation, and there is the entire range is included, etc. Data centers, none of that. And that's not because data centers don't want to, like your employers, it's not that they don't want to, it's just that the process just simply doesn't exist. So that kind of stakeholder engagement is lacking and should exist in the future. What is super interesting, and I actually, because Stu said, oh, I worked in the United States and I actually worked on building or working on a data center in Virginia, and I said, well, that's super interesting to hear because I read an article this morning about how in the United States, the future of data centers is a key point of contention for the US upcoming midterm elections in both parties, both. So even within the Republican Party, they disagree with each other. What should we do with data centers? How should we, are we pro, are we con, and why? So there are like these wild statements going around saying that Thai billionaires are coming to steal your money, so don't support data centers. They're not entirely wrong, there's probably a grain of truth in that, but also 99% of data centers, what you guys offer is what society is actively using on a daily basis. So it's obviously a very abrasive statement. But yeah, the fact that just something that is in essence just an industrial unit, which is now very different from a refinery or any other kind, is such a point of contention in one of the most important elections. It's just wild. And that just kind of goes to show, no, policy has no idea how to deal with it. There are blueprints from other sectors and other industries. Whether or not that can be followed is the question. Do you have, from like an ASEAN perspective?
From myself, rather than say policies, I look at possibilities. So maybe I can touch on things that I'm really working on. Because in terms of possibilities, other than the ones that we've been mentioning, I've already been in touch working on projects that are even like, you know how solar used to be just horizontal roofs and all that. I'm even now looking at projects where there's vertical buildings that can offer solar power. So that's where I even think, as we are doing data center, if vertical solar, because it is becoming a reality, I'm really doing projects that could that even be integrated into solar. And of course, the other key thing is about the water. I think water immersion cooling is another big one. And the other project that I have at hand in terms of possibilities, it's also on the battery. I feel that a lot of the battery storage, the advanced innovation, that's something that we're looking in NUS. So definitely I'm up for discussion with any of you guys if you have any ideas of how to improve further. And also I think in terms of ASEAN, to also refer back on the policy, I think that's where Singapore can be an orchestrator in terms of the data center policy or how we can mitigate as a whole region, because Singapore is the strongest in terms of the data center governance. Compared to EU where things are very united, I think that's where ASEAN can come together to be a bit more responsive to things. Because often I find that maybe for you guys also, when you're dealing with regional roles, you realize that how come Malaysia is a different set of policies than the other. So that's where I think in terms of policy, there's a need to develop this further. And that's why I think besides policies, I look at possibilities.
very nice. Okay, maybe one last question, because 7:43 right now. Mr. Wong is already there. Is building the 3D model a very manual process, or do you use automating tools such as 3D scanning? Dr. Stu?
Yeah, it's quick. We tend to do that for our customers. They provide us with some kind of CAD or floor plan, and that will be done overnight and ready for the morning. So it's quick. Most of our customers, when they're using the software, become really adept at it and moving things around. Like I said, it's like Roblox. So Roblox data centers really. So it's a very simple tool. But we take care of the first bit so that the room's about right, and then in commissioning we tweak it a bit. But it's not a. It's all designed to be the last thing you need to worry about, because it's all about running data centers and squeezing that last bit of efficiency out of the de-risking. It's not about spending time moving models around. That's designed to be really easy.
All right, maybe before we wrap up, just to add on a little bit more about EkkoSense, I can play a 1-minute video about us that give you a summary of what we are about.
All we need is a clear picture, and it doesn't get any clearer than EkkoSense. Watch the data behind your data center.
So that's how our digital twin platform looks like.
Everything there is to know.
You can see all your rooms in one page.
Hyper-efficiency.
And yeah, if you replicate the data, it's very fast, because
Chronos.
Control C and Control V.
Reduce cooling energy costs.
And this is our machine learning platform.
Release critical power and cooling capacity.
Yeah.
Reduce power difference. And solve your ESG reporting headaches. Real-time visibility across your enterprise. Working power management. And see
Yeah, so we can connect power as well as thermal side.
intuitive, cost-effective, and globally accessible. And it starts with the demo. Book yours today.
And maybe since the question is about how the digital twin looks like, let me play one more video that says capacity planning.
Are you tired of managing critical energy capacity with time-consuming spreadsheets and complex, expensive TCIM products? Now, you can track and manage cooling, space, and power demands in real time with a single intuitive system. EkkoSoft Critical. Whether one room to a full estate, you can oversee critical capacity across the whole power chain, from mains controller down to rack level. Capacity requests are easy to add to the live model. Determine the best locations to support your power requirements. Ensure your cooling performance remains optimal and help you
So we can just drag and drop the racks really
faster, smarter decisions. Look at them today.
Okay. All right, so that's the, let's go back to the, any questions, any more questions I can take from the floor right now? One last questions? Okay, all right, then we can thank you for our panelists, Dr. Stu, Tina, and Sharon, for sharing such a valuable insight today. We have heard how innovation, sustainability, and technology agility are not separate goals, but interconnected pillars that will define the future of resilient data centers. So I also want to thank everyone today, the audience, for your energy and participation, your questions and reflection, and your contribution for the event tonight. And we understand that resilience is not built in isolation, but it's a collective effort across the technology, regulation, and people. So thank you everyone tonight for the participation, and if you need any more questions, feel free to connect to the panel here today to if you need further information.